a common denominator to use. So there are several ways to go about doing this. Let's take an easy problem, such as 3/4 plus 2/3. One way to find a common denominator would be to list multiples of 4 and 3 until you have one you have in common. I always start with the first, or with the larger number. So I would start with 4, and I would list multiples. So 4, 8, 12, 16, and so on. Then I could list multiples of 3, 3, 6, 9, 12, and I can stop when I have 1 in common. So here you can see that I have 12 in common. So that means that I could make equivalent fractions with a denominator of 12. So if I want to make a fraction equivalent to 3/4 with a denominator of 12, I know that I multiply 4 by 3 to get 12. So I need to multiply 3 by 3 to get 9. Remember, whatever you do to the numerator, you have to do to the denominator, and vice versa. In order to go from 3 to 12, I have to multiply by 4. 2 times 4 gives me 8. And now I can add straight across. 9/12 plus 8/12 gives me 17/12. Now the answer 17/12 is fine, but if we want to make it a little easier to understand, if we want to simplify, we would turn 17/12 into a mixed number. One way of doing that is to divide 17 by 12. I know that 12 goes into 17 one time. So 1 is going to be my whole number. My remainder becomes my numerator. So I'm going to have 5/12 left over. So the answer in its simplest form is 1 5/12. Another way of solving addition and subtraction problems with fractions is to use something called the butterfly method. Now I'm going to solve this same problem using the butterfly method so that you can see that it's exactly the same. When we learn to compare fractions, I'll do this in a different color. When we learn to compare fractions, we learned cross multiplication. And the reason cross multiplication works is because what you're essentially doing is creating equivalent fractions with like denominators. So this whole idea of cross multiplication, when you're comparing fractions, can work exactly the same way. So here, if I multiply 3 by 3, I get 9. If I multiply 4 by 2, I get 8. So when comparing fractions, now you know that 3/4 is larger than 2/3. But what you're essentially doing is you're creating equivalent fractions with like denominators. What you're doing is you're multiplying 3 by 4 to get a denominator of 12. So now we have the exact same problem up here. We have 9/12 plus 8/12. So that's why the cross multiplication works when you're comparing fractions, because really what you're doing is making fractions that are equivalent with like denominators. So let's take the problem 4/5 plus 1/3. If I wanted to use the butterfly method to solve this, I'm going to use that whole cross multiplication idea. And what I'll do is, first of all, I'll multiply my numerators, and that's going to give me a common denominator. So 3 times 5 is 15. Now I can use my cross multiplication or my butterfly method. 3 times 4 gives me 12. 5 times 1 gives me 5. And now my problem is 12 fifteenths plus 5 fifteenths. So if I add those straight across, I get 17 fifteenths. And if I turn that into a mixed number, I know that 15 fifteenths would make 1. And then I'm going to have 2 fifteenths left over. So it's a pretty simple method for adding and subtracting fractions with like denominators. Let's try one more. Let's take 8 ninths, and we'll do a subtraction problem this time. 8 ninths minus 1/4. So I'm going to use this butterfly method. I know that 4 times 9 gives me 36. So what I did was I created a like denominator. 4 times 8 gives me 32. 9 times 1 gives me 9. Now this works because to get from 4 to 36, I have to multiply by 9. So whatever you do to the denominator, you also do to the numerator. So 4 times 9 gives me 36. 1 times 9 gives me 9. 9 times 4 gives me 36. 8 times 4 gives me 32. That's the reason it works. So now I can subtract straight across. So my denominator is going to stay the same. And then 32 minus 9 is going to give me 23. The same strategy will also work with mixed numbers. So if we had 1 2/3 plus 2 1/6, we can go ahead and add our whole numbers. So 1 plus 2 gives us 3. And then we can use the same strategy for our fractional parts. So I know that if I use my cross multiplication, I know that 3 times 6 gives me 18. So 18 is going to be my common denominator. 2 times 6 gives me 12. And 3 times 1 gives me 3. So now I can add my fractional parts. So 12 plus 3 gives me 15. I'm going to write my answer over here. So I'm going to bring my whole number over. 12 plus 3 gives me 15. And my denominator stays the same. Now there are times when you're subtracting mixed numbers that you're going to have to do something called borrowing. Just like you have to borrow when you have a smaller number and a place value in regular subtraction, you also have to borrow when you're subtracting fractions if your fractional parts don't work out. So let's say we have 4 1/4 minus, we'll just make it easy for now and say 4 3 or 1 3/4. Well, you can't flip your numbers around. That's one mistake that my students often want to make. You have to look at fractional parts first. And you can't subtract 3/4 from 1/4. So what you're going to do is you're going to borrow a whole. So you're going to cross out that 4 and you're going to borrow a whole. You're going to make that a 3. You're going to take your whole and you're going to make it into a fraction. So since we already have fourths here, how many fourths would it take to make 1? Well, it's going to take 4/4 to make 1. So we're going to redistribute this. We're going to say, okay, now I have 3, and then 1/4 plus 4/4 gives me 5/4. So now we have a problem we subtract 3/4 from 5/4 to get 2/4. And then 3 minus 1 gives us 2. If you were solving a problem like this using unlike denominators, let's say we have 4 and 1/3 minus 1 and 2/6, the first thing you want to do is you want to make your denominators the same. You want to create like denominators. So I know that if I have a 6 and a 3, I can use 6 as a common denominator for these numbers. So 3 times 2 would give me 6. 1 times 2 would give me 2. So now I've got 4 and 2/6 minus 1 and 2/6. And I actually don't need to borrow it this way. 2/6 minus 2/6 is 0. 4 minus 1 is 3. So, the best laid plans. Let's say we'll do 4 and a third again. And then let's say I want to subtract 1 and 3/5. I know this one will work. So I have to create equivalent fractions with like denominators. So I could use my butterfly method. I could come over here and I know that 3 times 5 gives me 15. 5 times 1 gives me 5. 3 times 3 gives me 9. So now I've got 4 and 5/15 minus 1 and 9/15. Well, clearly I can't subtract 9/15 from 5/15, so I'm going to borrow. I'm going to take a whole away. Now don't get confused and just add a 10 here. That doesn't work. What you're going to do is say, well,